Hello, my name is Courtney Boyd, and today I will be presenting a content-based image retrieval system with application in microbiology. Here is the table of contents for the project I am presenting today. Introduction. So, from the selfies that we take and post on social media to the images law enforcement use to identify perps for criminal offenses, we generate tons of images every single day. But the way that we retrieve images is just as important as the way that we generate these images. Content-based image retrieval, CBIR, takes advantage of image histograms to analyze and compare unique features. Similar images can be selected from a database using CBIR. In this project, we will review the development of a CBIR system with the query by example method for input and a Euclidean distance calculator. The CBIR system will then be evaluated for accuracy and applicability. The literature review for this project included papers by Schaefer and Shao, as well as a book by Tayagi. These references gave a lot of information about the type of distance calculation that we wanted to perform, L1 norm, which is known as the Manhattan distance or the Euclidean distance, which I will further elaborate on later in this presentation. We also, in the other papers, I also read about different methods for query. There's query by example, which is used in this project. There's also query by color palette, wherein a few colors are selected instead of a whole image. Furthermore, especially in the use of the Tayagi book, the differences between content-based image retrieval and other retrieval methods were analyzed. So, on to the method that was used for this project. For this project, the image type was all JPEG images, varying in size. So to prepare our images, we converted RPG images into a 6-bit color code. And then because the images had varying sizes, we used histogram normalization. Now, in order to compare the images, we found the Euclidean distance between two vectors, a vector representing each image. The Euclidean distance formula can be referenced at the bottom of this PowerPoint. Query by example was used in comparison to query by color palette, which, as I was saying before, is when you select a couple of colors that you would like to be present in your image. Of course, query by example is selecting an image that you want other images to be similar to. So after we've allowed the user to pick the image that they want, query by example, we then rank the top 20 images going from the most like the selected image to the least like the selected image. And here are the results. So first we used this marketing database of images. The reason we wanted to use that first was because, as you can see in the figure to the right, it had a very clean, minimalistic design. You see the white backgrounds, you see the distinct shapes and the limited color palette. This is to ensure that we, the user or the developers, can easily identify correct image selection from incorrect image selection. For example, in the images, you can see very clearly that the top row is very similar to the queried image in question, which is in the top left corner of the figure. The only difference in, let's take, for example, the first row, you can see where the holly in the upper right corner of each of the images is different from the little ribbon in the upper right corner of the images that are not as similar towards the top right. It's very simple in these images to see what is wrong and what is right. And that's why it was an excellent starting basis. However, for this project, I was very interested in the application of the CBIR to a microbiology database for novice microbiologists who may be still learning how to identify different microorganisms. So the microbiological database images were gathered from the online platforms of Chloe Savard, a microbiologist based in Montreal, Canada. So these images were a little bit more difficult for a CBIR system to identify. As you can see, there's a lot more background images. There's a lot more diversity in the color. There's more noise. There's more complex shapes than the other database that we had just been looking at. However, the results, as you can see on the right, speak for themselves. So one of the things that I really wanted to identify was the tardigrade. So as you can see, the tardigrade is the image in the top left corner. And all of the images 1 through 9 are all tardigrade images. So it was very successful in identifying the tardigrade. And as you can see in number 10, the Cimbella was probably the most like the tardigrade of all of the microorganisms inside of the database. So it's very good that it also ranked that one very high up, but after the rest of the tardigrades. So again, here are my references. And now let's do a quick little demo of the CBIR system that was created. I've nicknamed it Tardigrade. See, because tardigrade, okay. Tardigrade CBIR system. So let's check out how that's going to work. The software in question is MATLAB. A very popular software for image processing techniques. It's taking a minute to load here. So let's take a look at our CBIR database or a CBIR image retrieval system. First, the user is allowed to select their query image, and the query image is, we are able to get the histogram count for said query image. Let me say first that we, as I explained in the methods portion of the presentation, we convert the RGB image to a 6-bit color-coded image using this function, which utilizes the built-in bit shift that MATLAB already has, and a polynomial method. Okay. Next, we get the histogram count using this function. And as I was saying before, our images vary in size, so we were required to normalize our histogram count. The image is then, so we load the database, including all of the other images from our microbiology set. We set the size of the distances because we want to pre-allocate that space. We calculate the Euclidean distance for each of the images and save that. Then using a MATLAB built-in function called sort rows, we're able to rank the distances from the most similar to the least, meaning from the lowest distance to the farthest distance. And we're able to save that into an additional MATLAB function. And then we are able to plot our query image and then all of the subsequent 20 top 20 images. And let's just run it. Let's do the tardigrade. Tardigrade. And there we have it. Our top 20. Ta-da. Now, it also works with other databases. So I can run it with the marketing database that we saw earlier. Beautiful. And it can be used for a variety of other databases. The applications are really endless. Okay. And that was our demo. So in conclusion, a successful CBIR system was developed. We used Euclidean distance, inquiry by example. We were able to find the top 20 most similar images, and we were able to solve a real world image retrieval issue, which was identifying the tardigrade out of all of the microbiology photos in the set. To improve this project in the context of the microbiology application, I would suggest as a best practice to use consistent background colors and dyes. And as a improvement to the system in general, meaning regardless of the application, I would suggest including the segmentation techniques, which were elaborated on in the Tyagi reference. Thank you so much for watching my presentation. I hope that you enjoyed it. If you have any questions or concerns, feel free to reach out to me. My email is here on the screen. Thank you so much.